Sometimes subtracting mixed numbers can get a little bit more complex, as in a case like this. If we try to do exactly what we see that we've been doing, where we're going to subtract the whole number with the whole number, 9 take away 3, and then 1 over 4 take away 3 over 4, we're going to run into a problem, because we're going to recognize that a quarter is too small to be able to subtract 3 over 4. So in a case like that, we have to do what we usually do when we subtract, which is borrow. So we need to borrow from the 9 in order to get this fraction to be big enough so that we can subtract it with this fraction. And the way that we do this is, again, if we're going to borrow from the 9 is going to become 1 less. So the 9 will become an 8. The 1 that we borrow from the 9 has to get combined with the quarter. I could look at it this way. I could look at it like I take the 1 and I have the quarter and I change this mixed number into an improper fraction. And if I change this to an improper fraction, it becomes 4 times 1, which is 4, plus 1, which gives me 5. So this is 5 over 4. So this 5 over 4 becomes this here. So the 1 that I took from the 9 gets combined with the quarter. You can also look at it as a quarter as 1 out of 4, and the whole that you borrowed as 4 over 4. And if you add that 4 over 4 and that 1 over 4, you get 5 over 4. Alright? So this is the major part. Once you've done that, so this is actually this mixed number here. Once you've done that, you can continue with your subtraction. Minus 3 and 3 over 4. Now notice now that your first fraction is big enough that you can subtract it with your second fraction. So now you can go ahead and do your calculation as normal. 8 minus 3, that gives me 5. And then 5 over 4 minus 3 over 4 gives me 2 over 4. I could reduce this and my final answer would be 5 and a half. So sometimes we might need to borrow in order for us to get the first fraction big enough to be able to subtract. Let's try another one. 7 and 1 over 6 minus 2 and 1 over 4. If I'm given this problem to do, I follow the same approach. But again, notice in this case, my denominators are different. So the first thing I need to do is to try to get my denominators to be the same. So I'm going to rewrite it by saying my timetables for 4 and 6, timetables for 4 and 6, first number I'm going to run into is actually 12. So my denominator will actually be 12. So my problem now becomes 7 and something over 12 minus 2 and something over 12. 6 times what gives me 12? 6 times 2, so I multiply 1 by 2, that gives me 2. 4 times what gives me 12? 4 times 3, so I multiply 1 by 3, that gives me 3. And notice again what happens. If I go ahead and try to subtract 7 minus 2, I can do that, but when time comes to subtract 2 over 12 and 3 over 12, I recognize that this fraction is too small. So I do the same thing. I go to 7 and I borrow a 1. If I borrow a 1, a whole from the 7 now becomes a 6. The 1 that I borrow has to combine with this. Take note, I can view the 1 that I borrow as 12 over 12, because 12 over 12 is a whole. If I do 12 over 12 plus 2 over 12, I get 14 over 12. And then I can just continue my subtraction. Now notice this fraction is big enough that I can do my subtraction. So I go ahead and just continue my subtraction as normal. 6 minus 2, that gives me 4. 14 minus 3, that gives me 11 over 12 right here. So again, the key is borrowing. And that borrowing, so if I borrowed from the 7 here, the 7 must become a 6 because I borrowed a whole, which is 1. Remember, a whole can also be viewed as the same number over the same number. So in this case, I can say my whole is 12 over 12. Take that 12 over 12 and combine it, add it to this 2 over 12, and I get 14 over 12. So this fraction now becomes 14 over 12, and I can go ahead and do my subtraction.